Hi children, today you are going to learn 7th class 4th chapter, that is lines and angles. In that, exercise number 4.6 and 4.7. In this video, we are going to cover the two exercises and also complete this chapter. So, without wasting time, let's start the 4.6. This 4.6 is based on the vertically opposite angles. What? Vertically opposite angles. Vertically opposite angles. What are the vertically opposite angles? You know it. You might be seeing alphabet X or a danger symbol, or not when scissors are opened, the angles formed oppositely. They are called as vertically opposite angles. These two angles here, suppose A and B, these two angles are vertically opposite angles. These vertically opposite angles always equal. Here, angle A is equal to angle B. Vertically opposite angles is always equal. This you need to remember. And the angle formed at this point is completely. Suppose this is C and D. Here angle C equal to angle D. And sum of these all angles, angle A plus, angle B plus, angle C plus, angle D equal to 360 degrees. Sum of this all the angles equal to 360 degrees. The angle at a point is give us 360 degrees. This complete angles. So the next exercise is 4.7 exercise is based on transversal. When two lines are parallel and one line is intersecting two parallel lines at two distinct points, the intersecting line is called as a transversal. So if it is L and M and this is N, if L and M is parallel, then N is a transversal. N is a transversal. Then here 8 angles will form. 1, 2, 3, 4, 5, 6, 7, 8. Then alternative interior angles and alternative exterior angles and the corresponding angles. One interior, one exterior angle is known as the corresponding angle of the same side of the transversals, and alternative exterior angles, sum of two adjacent angles is equal to 180 degrees. So these all angles are equal. About this concept I have given you in the introduction class of lines and angles. There we have learned everything. So we are going to solve such a problems in the 4.6 and 4.7. So let's start the problems from the 4.6 first. Here they have given one picture in the first bit. The first question is, there is a line AB here, A and B, and there is a line CD here, C and D, and there is a one more line here, that is E. So these all lines are intersecting at O. So, name the pair of vertically opposite angles in the figure. What are the vertically opposite angles in this figure? So, here angles are formed. Yes, let us write that. See, these two angles are vertically opposite angles. Where I am giving a star mark. See, I will write that now. Vertically opposite angles. The first one, the first pair is see. Angle AOC, this angle AOC is equal to angle BOC. Sorry, here is D side, C and D. So AOD is equal to BOC. And the next one, see that here angle AOC, this complete angle, this complete angle is equal to this complete, not a single part. We have to forget about this line. See that these two angles are vertically opposite angles. So imagine that there is no line like a OE. So we write now angle AOC is equal to angle BOD, not BOE. This complete angle is not opposite to the equal angle here. The same length of an arc is not equal to this arc. So this complete arc we have to take. That is this complete angle. So angle AOC equal to angle BOD. So these are the pair of vertically opposite angles in this given figure. So there is a one more question in this. We go for second one. X, Y, Z and 160 degrees. Find the measures of X, Y and Z without actually measuring them. So without using a protractor, find out what is the value of X, Y, Z. So we know that vertically opposite angles are equal. First thing, we know that from figure, the vertically opposite angles are equal. Opposite angles are equal. So what are the vertically opposite angles here? Angle X equal to angle Z. That means X equal to Z. Angle X is equal to angle Z. And also angle Y equal to 160 degrees. So these two are vertically opposite angle and these two are vertically opposite angles. And now you see that sum of this all the angles is equal to 360 degrees. Okay. The angle at a point O, suppose the angle at a point here that is equal to sum of angles X plus Y plus Z plus 160 degrees equal to 360 degrees. Okay, so this all angles equal to 360 degrees, and we have to apply that instead of angle X. Okay, instead of angle X, we'll keep a angle Z, or instead of angle Z, we'll keep a angle X. So here angle X, no, we keep it here like a X, and here angle Y is equal to 160 degrees plus angle Z. Here angle X equal to angle Z. So here instead of angle Z, I'll keep a angle X plus 160 degrees equal to 360 degrees. 160 plus 160, 320 degrees. 1x plus 1x is 2x. 2 angle X equal to plus 160 plus 160, 320 degrees is equal to 360 degrees. This 320 degrees will transfer the other side, so that 2 angle X equal to 360 degrees minus 320 degrees. Then 2 angle X equal to 40 degrees. Here 2 ones are 220s are there. Angle X equal to 20 degrees. If angle X equal to 20 degrees, then angle Z also equal to 20 degrees. So we got a Y, angle X equal to 20 degrees, therefore angle Z is also equal to 20 degrees. So we got all three X, Y, Z without actually measuring them by protractor. And there is a third question here. We have to give your own examples, that give some examples of vertically opposite angles in your surroundings. Just look at the surroundings where the vertically opposite angles are formed. Just you have to give your own answers. Like see in the alphabet X, the vertically opposite angles are formed, and also then in cycle wheels the vertically opposite angles are formed, and bike wheels, and also when in the danger symbol or normal you can see in the transforms, a big electricity supplies place, they'll keep a danger symbol. So there you can find the vertically opposite angles. We have to give some examples such where the vertically opposite angles are formed. So with this exercise is completed. Now we can go to the exercise number 4.7. In the 4.7 exercise, we are going to learn that about transversal and two parallel lines and transversal. So let us start that exercise also. Here in the seventh bit, first question, that means the first bit is completely filling the blanks. The filling the blanks. First one, see that the line which intersect the two or more lines, the line which is intersect the two or more lines at a distinct point is called dash, that is transversal. A line is intersecting two or more than two lines at two distinct points. This line is called as a transversal. Transversal. So next, in a pair of alternative interior angles are equal, then the lines are called. Suppose these two alternative angles or these two alternative interior angles are equal, then these two lines are known as L and M. Suppose L is parallel to M, then the lines are called as a parallel lines. The third filling the blank, the sum of interior angles of the same side of the transversal is supplementary, then the lines are called. Suppose the sum of two angles is 180 degrees, then these lines are called as a 180 degrees. Suppose these lines are called as again parallel lines only. If sum of two interior angles, these two are interior angles, the sum of two interior angles of a same side of the transversal is a supplementary or 180 degrees, then these two lines are called as a parallel lines. See that if two lines intersecting each other, then the number of common points they have. See that here it is one more line and this is a one more line. If two lines are intersecting each other, the number of common points they have only one. They have only one common point. So I hope you understood this first bit of 4.7. Now we have a second bit questions. The second bit questions is based on this diagram. You have to understand this diagram clearly. Here it is a N, L and M. 1, 2, 3, 4, 5, 6, 7 and 8. So here in the adjacent figure, L and M are parallel, L and N is a transversal. Fill in the blanks for the situation given below. So here we have to go for the filling the blanks only, second bit also. Fill in the blanks are that if angle 1 equal to 80 degrees, then angle 2 equal to dash. So the second one, if angle 3 equal to 45 degrees, then angle 7 equal to dash. Then the third one is if angle 2 equal to 90 degrees, then angle 8 equal to dash. Fourth one, if angle 4 equal to 100 degrees, then angle 8 equal to dash. Okay, these are the situations are given. In these situations, what will be the next angles? Let us see. Here, angle 1 equal to 80 degrees. Then what about the angle 2? These two are the adjacent angles, are not a linear pair angles. By the linear pair condition, I can say that sum of these two angles equal to 180. So one of the angle is 80, then the other angle should get 100. Then only they make say 180 degrees. So they are by the condition of here linear pair condition will come. Linear pair. The linear pair condition will satisfy here. How you got 100 degrees? By the linear pair condition, the sum of the two adjacent angles will give us 180 degrees are supplementary. Next, if angle 3 equal to 45 degrees, if angle 3 equal to 45 degrees, then angle 7, see that these two are alternative interior angles, so this also will be equal to 45 degrees only. So these angles are for the condition of alternative interior angles, by the condition of alternative interior angles, angle 3 equal to angle 7, angle 2 equal to angle 6. Alternative exterior angles, angle 1 equal to angle 5, angle 4 equal to angle 8, the both the side of transversal. Then if angle 2 equal to 90 degrees, if angle 2 is suppose 90 degrees, then angle 8 also 90 degrees only. How? By using a vertically opposite angles condition. Vertically opposite angles. They are vertically opposite angles. By that condition, these two angles are having same measurements, that is 90 degrees. If angle 4 equal to 100 degrees, whatever the angle 8 also is equal to 100 degrees only. This is the condition of alternative external angles. Here alternative internal angles, here alternative exterior angles. So these are the conditions. With that, we have filled this filling the blanks. I hope you understood this. If you understand this concept, then you can do the remaining problems of this exercise 4.7. These problems are very important for the examinations. There are 4 more problems here, word problems. Third one, find the measures of x, y and z in the figure when L is parallel to BC. Suppose there is a triangle here and there is a line here L, and there is a B and C here, y degrees, z degrees, x degrees, 75 degrees and 45 degrees. We need to find out the x, y, z values in this figure. So let us find out the x, y, z. So first, as given that is L is parallel to BC. Line L is a parallel to BC. These two lines are parallel lines. Hence, if these two lines are parallel lines, okay, see that if first of all we will find out the angle x, then we will go for angle y and z. Okay, sum of these three angles, the angle at A, vertex A equal to 180 degree. That means sum of these three angles equal to, it makes a semicircle or supplementary, or it is a straight line. The angle A is a straight line, so 180 degrees it forms. So sum of these three angles, 75 degrees plus x degrees plus 45 degrees equal to 180 degrees. 75 plus 40, that is 120. X plus 120 degrees equal to 180 degrees. This 120 degrees you transfer this side, x equal to 180 degrees minus 120 degrees. Then x equal to 60 degrees. So x equal to, we got 60 degrees. Then next, when L is parallel to BC, see that for these two parallel lines, here AB is a transversal. Then AB is a transversal. Then here, if AB is a transversal, then alternative interior angles are equal. So angle Y equal to 75 degrees. Angle y equal to 75 degrees. Have you got this angle y equal to 75 degrees? Here alternative interior angles. They are alternative interior angles. Our next condition, see, same when L is parallel to BC again, then here in this condition AC is a transversal. If AC is transversal, Z equal to 45 degrees. Then AC is a transversal. Then here angle Z equal to 45 degrees. This also say alternative interior angles. This also alternative interior angles. I hope you understood this. The next problem, we'll go for the next problem. We got x, y, z values in this given figure. Overall, there are 6 questions. Now there is a 4th question here. ABCD is a quadrilateral. Here they have given a one ABCD. A, B, C and D is a quadrilateral. In that angle A equal to 50 degrees, BE, here C and here D angles are given. Yes, ABCD is a quadrilateral. That's right. Given that ABCD is a quadrilateral and AB is parallel to DC. AB is parallel to DC and AD is parallel to this. AD is parallel to BC and AD is parallel to BC. Find the angle B, C and D. So remaining 3 angles we need to find. See that here in this sum of 2 adjacent angles, or sum of these 2 adjacent angles, or sum of these 2 angles adjacent angles, or sum of these 2 adjacent angles are equal to 180 degrees. So let's go for that. In this, suppose these 2 are parallel lines, and if AD is a transversal, sum of these 2 angles equal to 180 degrees. Sum of 2 interior angles of a same side of the transversals. See, if when AB is parallel to DC, here AD is a transversal. Here AD is a transversal. Here AD is a transversal. Then here angle 50 degrees plus angle D. 50 degrees plus angle D equal to 180 degrees. By what condition? The sum of 2 interior angles are same side of transversal. Sum of 2 interior angles of a same side of transversal is equal to 180 degrees. So this 50 degrees if you transfer this side, angle D equal to 180 degrees minus 50 degrees. Angle D equal to 130 degrees. So here also sum of these 2 angles. See, when AD is parallel to BC. Now the second condition, we'll go for the angle D. When Here AD is parallel to BC. Here we need angle B, no? So AB is a transversal. Here AB is intersecting these two parallel lines. AB is a transversal. So see that sum of these two angles equal to 180 degrees again. 50 degrees plus B equal to 180 degrees. Same again, the same condition will come. Sum of two interior angles of same side of the transversal. Sum of two interior angles of a same side of transversal. So this 50 degrees will transfer this side. B equal to 180 degrees minus 50 degrees. Then B equal to 130 degrees. So this is 130 degrees and angle D also 130 degrees. So here similarly by the same condition, here directly I can write R0. We will go for the one more now. If AB is parallel to the DC, now in this case you take BC is a transversal. 3 times you can do it. When AB is parallel to DC, here BC is a transversal. For these two parallel lines, BC is intersecting. So BC is a transversal. So here what happens, see, angle B plus angle C equal to 180 degrees. The same condition again what I have written here. So here angle B we know that 130 degrees. We will substitute here 130 degrees plus angle C equal to 180 degrees. This 130 degrees will transfer this side. C equal to 180 degrees minus 130 degrees. C equal to 50 degrees. So here C equal to 50 degrees. So we got all the angles here. B, C, D. Here D, here B and C. The same concept we used when two lines are parallel. If one line is intersecting two parallel lines, that is called transversal. The sum of two interior angles of same side of the transversal is equal to supplementary R0 180 degrees. R0, the two angles are linear. Linear is nothing but a 180. Okay, we go for question number 5. In the given figure, L and M are intersecting by a transversal N. Here, this is a line L and M. It is intersected by a transversal N. So they have given a name. It is a AB line. It is a CD line. And here point P, S, Q, R. So in this they have given only two angles, that is here 100 degrees and here it is 80 degrees. So when L is parallel, L is parallel to M, is asking that here L and M are parallel or not. To prove that L and M are parallel, here we have to show that either alternative interior angles are equal or alternative exterior angles are equal or alternate corresponding angles are equal. This any one of the condition we have to prove it. So let's see that here sum of these two angles, the sum of two angles, so angle AQP, here angle AQP plus angle CRS is equal to, okay, that equal to, we have to get 180 degrees. These are the corresponding angles. So sum of two external angles we can say. Sum of two external angles. Here you can take it R0 what we can do it in other way, we can tell that here by the linear pair condition, if you write here 80 degrees, if a linear pair condition, if you write 80 degrees, okay, then we can go for this 80 and 80 are equal, alternative exterior angles are equal. In that condition we can go for that or not. We go for only that. We go for that. Yes. By the linear pair condition here, angle AQP plus angle BQP is equal to 180 degrees by the condition of here linear pair. These two makes a linear pair because it has a common vertex and common horn. So angle AQP, it is 100 degrees plus angle BQP equal to 180 degrees. This 100 degrees should as well as that angle BQP equal to 180 degrees minus 100 degrees. That angle BQP equal to 80 degrees. Here we got 80 degrees. Now we can say that here, now from the figure, angle BQP is equal to angle CRS. Angle CRS, that equal to 80 degrees. That means here alternative exterior angles are equal. Here alternative exterior angles are equal. When the alternative exterior angles will be equal, when two lines are parallel, then only alternative exterior angles or alternative interior angles or corresponding angles will be equal. So here you can take here 80 degrees or that 80 degrees you can take it here and show that they are corresponding angles also. If you write here sum of these two angles are equal 180, then these two angles are known as the corresponding angles. According to the corresponding angles, we can say that L is parallel to M. Or not, I have done here these two angles equal to 180 degrees by the linear pair condition, or here also you can take a linear pair condition and show that according to the corresponding angle, or not, here alternative external angles are equal. Whatever, if alternative interior or alternative exterior or corresponding angles are equal, then when they will be equal in the sense when two lines are parallel only. So we can say that, here L is parallel to M. Here L is parallel to M. Why? Because alternative exterior angles are equal here. Here if you write 80 degrees, alternative corresponding angles also will be equal. So in this condition I can say these two lines are, the L and M are parallel lines. And the next one and the last question of this exercise is that question number 6. Yes. Now here angle A, here it is 50 degrees. Here it is angle B, here is angle C, here it is angle D, here it is angle E, and here it is a 50 degrees. And see that this angle, this line and this line are parallel. These two lines are parallel. This line is the intersection. And see that two arrow marks I am showing, so that these two lines are parallel. This is transversal. Now here these two lines are parallel and this is a transversal. And here after here it will be, see that one arrow marks lines are parallel to each other. The two arrow marks lines are parallel to each other. Yes. Then find angle A, B, C, D, E. Here in the figure give a reason. So as he said that, so here angle A is equal to angle B is equal to angle C equal to angle D is equal to angle E equal to all 50 degrees only. Why? Because they all are alternative interior angles only. Because all these angles are alternative interior angles. Alternative interior angles. With this, we have completed this chapter. Keep practicing this chapter because this lines and angle chapter we have in 9th class also. The 9th class 4th chapter is lines and angles. If you want, you can go through the 9th class in my channel itself. There is a chapter I have already taught there. All the exercises from the 9th chapter, lines and angles. So watch that videos also, you get again more knowledge about this chapter again. Okay, I hope you understand well. Thank you for watching this video. Thank you all.